Who uses internet every day? Hands up. If you didn't raise your hand, you're lying, you can go out. Who thinks internet is reliable? Good. Who thinks that somewhere and somewhere could, by accident, bring down the whole internet in 5 minutes? Well, that doesn't even take 5 minutes. 3 minutes is enough. All right, you will be surprised. If you watched the Matrix movie, I'm giving you a red pill. Now is your time to go out and want to receive it. If you want to keep thinking how reliable internet is, go out right now. All right. Unfortunately, I've been dealing with internet since 1990s or so. I built the first commercial ISP in Slovenia. Then I started teaching BGP, the protocol that we'll talk about today, to networking vendors. I developed the BGP course for Cisco Systems, the biggest router vendor. Didn't write a book about BGP, but wrote a few other books about other topics. Here are the freeze faces. Recently, I've been dealing more with clouds and data centers and automation. But, you know, as BGP security became like a mainstream topic, they asked me to do this, and so here I am. We became aware of the security issues around 1997, when a small organization somewhere in Florida managed to bring down the whole internet. It was so bad that they came to the front page news of CNET, and so I was able to find an article about this a few months ago when I was preparing this presentation. So, internet remembers, remember that. Supposedly, it was a router bug. Oops. Yeah. And that supposed router bug, it was explained as a router bug. I don't believe it. I think it was a manual configuration error. That router bug made the whole internet look like it would be in Florida. And so obviously, everyone wanted to send all the traffic for everyone else to Florida. This didn't work out so well. Even worse, these people managed to advertise very specific prefixes for the whole internet. You know, oh, by the way, how many of you are networking engineers? All right. How many of you have ever worked with BGP? Okay, you two will be bored, as I'll try to make this understandable to everyone else. So effectively, when you get address space for your whatever website or cloud services or your network, that address space could be smaller or bigger. So the prefix size could be different. In the good old days, in 1997, we thought that all the prefixes should be of the same size. And so what these guys did was they received the advertisements from everyone else, cut those advertisements into those smaller prefixes, and re-advertised them. And so obviously, everyone believed that these smaller prefixes are better now. And so all the traffic from the whole world went to Florida. Problem number one, everyone else had no protection in place. So no one ever thought about this. No one ever thought that this could happen. There was no protection in place. So this is why these guys managed to bring down the whole internet. Problem number two, it took hours after someone figured out that this is wrong for that bogus information to disappear. Because in the good old days, a router would get an update, yawn, wait for 30 seconds, and then send the update to everyone else. Just in case, you know, something else came in the meantime, and why should we panic? So when you have long cycles, and every step of the cycle takes 30 seconds, you get hours. But okay, internet was young. You would think that we've learned something. We would think that things would get better. So what lessons did we learn? The answer is none. So this is what was really going on. We are running something called BGP in the internet. And no, it is not a bridging the gap protocol as Sky News believes. When Facebook went down for a day, it was all over the news, and it was, first they thought it was DNS, then he thought it was BGP. And then the poor guy on Sky News had to explain the Facebook outage to the general audience, and he had no clue about networking. So they told him that BGP stands for Bridging the Gap Protocol, which is absolutely not true. It's Border Gateway Protocol. And so now we have Bridging the Gap Protocol. Anyway, every network has a number. And every network is advertising what prefixes it owns. So this one would say, I am network 65,000 and I own this prefix. Now, what happened in Florida was that this guy in the middle split this into many smaller prefixes and then advertised those prefixes as belonging to him. The other problem we have with BGP is that the only metric we have is how long this path of numbers is. And by the way, it was one of those things that was invented literally between two guys sitting in a restaurant drawing on the napkins. BGP is a 3-napkin protocol because it took them 3 napkins to write down the specs and the state diagram. And we never implemented proper security for BGP. It was always meant to be used between friends. There was BGP 1, there was BGP 2, there was BGP 3, we're now at BGP 4. We've been at BGP 4 since 1990, something small. So for 30 years. They didn't make any significant changes to the protocol in the meantime, and so the whole internet is running on 30-year-old crap that is totally unsecure. Now we can go home. All right. So they were announcing more specific prefixes for the whole internet. The whole internet belonged to them, and, well, some people propagated that nonsense. You would think that some people would have learned a lesson from that, and some people did. Some people did learn that if you advertise more specific prefixes of someone else, that A, you will kill their traffic, and B, it will propagate. So when the Pakistanis became a bit upset about some YouTube video saying bad things about Prophet Muhammad, they decided to bring down YouTube. They sort of decided, supposedly, to bring down YouTube in Pakistan, but their fix escaped because their upstream provider was clueless. We all know who it is, but I will not mention any names this time. And so the whole thing escaped to the wider internet. So now you have YouTube here in California, and this was in 2008 when YouTube was still a small organization. I don't think they were bought by Google at that time, or maybe they were just acquired by Google. So they had one location in California. They had a few prefixes. They only connected to the internet in California. So they had a /22, which means they had 4 of the smallest possible prefixes. And they announced one prefix. Instead of that, Pakistan Telecom announced 4 more specific prefixes. Guess what? They propagated throughout the world because their upstream provider was stupid and didn't say, gee, guys, I don't think YouTube is in Pakistan. So one propagated that, and today there would be some impact, but not much. Because remember, we are talking about the length of those numbers, the length of the AS path. So if Google is connected at 100 places in the world, then all the paths to Google have short length. And someone in Pakistan has no chance of influencing someone in Europe because Google is closer to you in Europe than Pakistan is. So if you are big enough like Google is or Cloudflare is or maybe Facebook, then you don't have these problems because you are close enough to most people so that no one can just hijack your prefixes. In those days, Google was small, and this can still happen to any one of you. Someone hates you, you can be brought down. Now, because Pakistan advertised the minimum possible prefix size for the global internet, Google couldn't advertise more specific prefixes. They tried. It didn't work. So we've learned that, well, you know, anyone can hijack anyone else, right? Oops, what is this? Well, how do I start? Is this one? Yeah, good. So what have we learned from the past mistakes? Nothing. Right, which brings me to a fun hack. Someone a few years later said, well, gee, this worked so well for YouTube. Let me try that for AWS DNS servers. There was a crypto app running in AWS Cloud. And they were using the AWS DNS servers. And someone managed to hijack the very specific prefix in which AWS is running their DNS servers. And that gave them the control over the whole DNS infrastructure of AWS, which brought down like 1 million websites, but they were only interested in one, the server for the crypto app. So they hijacked effectively the DNS name of the server of the crypto app, redirected to their server, started grabbing the user passwords. They were disconnected in like 30 minutes and made hundreds of thousands of dollars in damages. Obviously, everyone else was collateral damage, but who cares? They got their money. So you would think this was, after all, what, 5 years ago? That we have learned something in the meantime. No. What's So we still haven't learned anything in the last 10 years. 2019, someone brought down Cloudflare, Facebook, Netflix, AWS, and a few other people. This small company in northern Pennsylvania wasn't the culprit. They were just, you know, sort of ignorant bystander. It looked like Cloudflare and Netflix were reachable through a steel plant in Pennsylvania. And this is what happened in real life. So Cloudflare is announcing some prefix, or Facebook is announcing some prefix. And that prefix is coming to whoever is observing this through this long list of autonomous system numbers, which is suspicious in the first place because, you know, Facebook should be closer to me. Now you go and you analyze the, let's say, Cloudflare one. It gets to level 3, which is one of the service providers in the US. Then it gets to some small provider somewhere. Then it gets to this poor steel plant. This is from their website. This is what they're doing. They're not crypto miners. They're actually making steel. Then it goes to Verizon, and then Verizon propagates this to Cogent, which is that one, and then it goes through something else to the probe. The problem was that these guys were using something called a BGP optimizer. And BGP optimizer, because I told you the only metric is the length of that AS path. Now, something could go through 2 networks and be really slow, but the alternate path through 5 networks could be fast. So there are people making money selling products that actually measure the speed of the paths and then tell you where to go. But to do that, they have to lie all around. And they're using the same trick we experienced in 1997. They create smaller prefixes and advertise them. And so the traffic is going where they want the traffic to go. Because we haven't learned anything from the Pakistani YouTube hijack, these idiots have default settings that are unsafe. You buy a product, and the product generates the prefixes that can escape into the wild internet. That's the default setting of this product. And it happened. And those more specific prefixes were leaked to a customer, the poor steel plant. So this is the mistake of the optimizer vendor. This is the mistake of the small service provider. This is the ignorant customer leaking those prefixes to Verizon because they don't know any better. And this is a huge mistake by what is supposed to be a large service provider. You are accepting hundreds of prefixes belonging to Facebook, Cloudflare, and Netflix from your customer. I would like to know what they were smoking, because I would like to have that too. This is like totally irresponsible. And then the next service provider to filter that. So a picture is worth 1,000 words. You need a triple facepalm for this. So can we fix this? And by the way, these are just the prefix leaking problems. There's also the problem of software quality. Networking vendors think that we should be their quality control. So they release the software, it has bugs, we report the bugs to the technical assistance center, they claim it's not a bug, you have to spend 3 days persuading them it's a bug, 6 months later they fix it. I've been through that too many times. Oh, by the way, these days, the level 1 technical support asks you, did you reload your router first? Yeah, sure, that helps. Anyway, Cisco systems had a bug in their BGP implementation. If you're programming, you know that if you have very small integer, you cannot count past 255. And in BGP, no one expected the string of numbers to be longer than 255 numbers. But someone said, well, yeah, we can make special provisions for paths that are longer. And Cisco never tested that. They implemented it, but they implemented it incorrectly, and they never tested it. So there was this small Czech service provider using some routers from some small European manufacturer that had commands that looked like commands from major router vendors, but did a different thing. So someone configured that box so that instead of adding their autonomous system number to the AS path twice, they added their autonomous system number like 250-something times. They had an autonomous system that had just the right 8 bits in the low order 8 bits. And so that thing was propagated. No one stopped that, because why should you? I mean, that's perfectly normal that one has, AS path length that goes from here to the other wall, right? Why should anyone ever check that? And when it hit a Cisco router at 255 numbers in the AS path, that Cisco router would send the wrong update to the next guy, and the next guy would go, "You're drunk, go away," and disconnect the session. Now, if that happens between, I don't know, Hrvatski Telekom and A1, everyone goes like, "Oh, okay." If that happens in the core of the internet, then the whole internet ripples. And that happened. And so this poor Czech guys managed to bring down the core of the internet because of a software bug in a Cisco router. Not their fault, actually, but they managed to do it. Another one. Someone from RIPE made an experiment and said, well, let's see how well unknown attributes propagate through the internet. Because, BGP is extensible, like everything is these days, and if you get an attribute that you don't understand, you either propagate it or you drop it. You don't crash. Well, some routers crashed. So that poor guy managed to bring down like 5% of the internet. That was years ago, and you would think that people would fix that, and they did. The standard saying, well, you really shouldn't crash your BGP session if you get an error. You should tell the other guy that, well, maybe, or be quiet, just ignore it. The standard was published in, 2015 or something, so 8 years ago. It is implemented in all major BGP implementations. It's just that the Juniper default setting is don't use it. So 8 years after we fixed the whole thing for good, and everyone implemented it, there is a major router vendor that has the default don't use this fix. And so a few weeks ago, someone from Venezuela or wherever started generating some random attributes, and of course the Juniper routers just fell over. Well, not exactly. They killed the BGP session with their neighbors. Same thing. So we never learn. Okay. Now for the real question. We fix it. And here is where comedy turns into tragedy. What if I told you that we had the tools for decades? So, I am an author of one of the RFCs that happens to be about BGP operations and security. We started writing that thing, and that thing is just a list of best practices. It's nothing new. It's nothing revolutionary. It's just documenting what's out there. We didn't invent anything. We just documented what was already available and how it should be used. It took us like 2 years to put this list of things that exist through IETF to make it into an RFC. So things that we really described existed 10 years ago, in 2013. And these are lists like, well, protect your BGP sessions, have filters that would stop all the attacks I mentioned so far, have per customer prefix limit that would stop the Verizon stupidity, then implement public key infrastructure for origin validation, which would prevent a few of the attacks I mentioned, and then have filters based on the public databases of who owns what and who is connected to whom. All these things have been in place forever. Maybe they weren't well maintained, but of course no one will maintain them if no one is using them. things we had available in 2013 would have stopped all the recent attacks I mentioned. It's just that no one ever implemented them. Which brings me to the next point. Why did that happen? And the problem is that the service providers simply don't care. I mean, yes, there are engineers in every service provider who are jumping up and down and pulling out their hair and saying, we shouldn't be doing things like this. This is insecure. And everyone else is going like, oh, yeah, where's the money? And there's no money in this. The people making the money off internet reliability are the content providers. Be it the YouTubes or the Facebooks or the Netflixes or your bank. Everyone else is making money off the internet, but no one will pay more for a secure internet service. When you're buying internet connectivity, you always go for the cheapest option. So why would anyone on the service provider side invest into tools that would make other people look good while not gaining anything out of it? That's the problem we've been fighting for the last 20 years or so. And it's not fixable. You cannot charge more. People don't care. Because you can't charge more, you don't have the money to implement it. And because you don't have the money to implement it, you cannot claim it's a differentiator. So no one will ever do it. Now, the only thing that works in a space like that is public naming and shaming. That's what I would do. That's what I've been doing successfully on my blog with networking vendors for the last 15 years, and sometimes it even helps. Sometimes they even fix a bug that they claimed was not a bug and document it in their documentation. Real life story. Anyway, there is a guy that's much better than I am at doing these things, Job Snijders. And he and a few others started this initiative called MANRS, which is a really nice acronym because, you know, you should have good manners. It stands for Mutually Assured Agreed Norms for Routing Security. So they put together a set of recommendations, and it's really not too hard to follow, where they're saying, well, you should filter propagation of incorrect routing information. So if a steel plant is telling you that they know where Facebook is, you go like, you're drunk, go home. Just this thing would stop all the attacks I mentioned. Second is anti-spoofing. I didn't even mention this one so far. You do know that people make denial of service attacks over the internet, right? And some of these attacks reach hundreds of gigabytes. So how can you generate hundreds of gigabytes of traffic toward one target? Well, you can have a huge botnet of webcams, but maybe each webcam can generate 1 megabit or a few megabits. And there is a gap between megabits and hundreds of gigabits. So you need an amplifier. Okay? So you go around, and one of the best amplifiers was Idiot, having the Memcache daemon servers running in public cloud and having it open to the internet, because who cares about security in public cloud, right? It's just for testing. Memcache daemon can be reachable over TCP, which is connection-oriented, so it's complex. It can also be reachable over UDP, which is one packet here, one packet back. Now, what really happens is let's say he is my target. So I tell all my webcams to send traffic to that guy over there with insecure VM in AWS, claiming that the source address of the request is really him. And because no one is implemented anti-spoofing, all the telecoms in the world, apart from a few exceptions, would go like, yeah, that's totally legit that I'm getting from my end user with a webcam an IP packet with source address that happens to be in California. The packets are accepted. They're sent over there to that guy that is amplifying them. He's sending the traffic to that guy over there, and he's brought down. You know what's the best part of this particular story? That guy in the cloud is paying for that. Because every public cloud provider is charging egress fees for all the traffic you're sending. So if someone is using you for the amplification attacks, congratulations, you're financing criminals. Anyway, so this is another thing that the service providers should be stopping, but many of them are not because it's hard and who cares. By the way, the best amplification attack ever was from a voice over IP conferencing system where you would send one packet to that conferencing system to put it in test mode, and then it would send streams to whatever IP address you wish for like hours. I think the amplification factor was something like 4 billions. You're sending 1 kilobyte, you're getting 4 trillions bytes to some target. Cool, right? The next thing that you should do if you are serious about your MANRS is coordination, which means please enter your data into the proper databases that have been around for the last 30 years. Start using the infrastructure that we have. And finally, global validation, because today we have the infrastructure where you can digitally sign with certificates and everything which prefixes belong to you. Now, this can't stop good malicious attacks. Okay? Because if you are saying this prefix belongs to me, I can still advertise a prefix saying, well, it goes through me and then it belongs to him. I don't have a path to you, but I'm lying. But because we're only validating the first, well, the last, the origin autonomous system, this attack succeeds. Well, not if he's well connected, because then, you know, my length is longer than his length and it's okay. But still, this thing stops all the fat finger incidents like the one between whatever service provider and Verizon. So that one would be stopped with this thing alone. So this is great. You put together a list of things that matter. Now, you have to go around conferences and promote that. Otherwise, no one will know about it. And then you have to persuade someone that it really matters. And I'll show you the result. So this is the number of participants, organizations, and autonomous systems. There are currently over 60,000 autonomous systems worldwide, so we are a bit off the target, but it's getting better. So if you are an address owner, so this is something everyone should do. Make sure that in whatever registry your network is registered, for Europe this would be RIPE. So if you own some address space, make sure that this information is up to date. So that if some shit is coming from your address space, at least everyone else will know whom to contact. This is like the absolute minimum you can do. If you're a service provider, then, well, you should register what you expect to see from others. You should create the route origin authorization objects for your prefixes. And you should document your routing policy in this object. So this is for everyone. This is for, unless obviously your service provider did this for you, in which case it's their responsibility. This is primarily for service providers because as an end user, you don't have a routing policy worth mentioning. For the transit providers, so this is everyone offering internet services to someone else. Doesn't matter if it's residential or mobile or enterprise services, everyone should do source address validation. So check whether the source address of the packet your customer is sending really belongs to your customer. It's trivial. It just needs to be done. There is something called unicast reverse path forwarding check. It's a trivial thing. If you want to deliver the traffic to your customer, you must have a route to your customer. So whenever you're getting a packet from somewhere, you look at the source address and you say, would I send the return packet in the same direction? And if the answer is yes, then obviously it's a legit packet. If the answer is no, then it's like, what is this packet doing here? I should drop it. It's like one line of configuration and people are not doing it. It doesn't even have performance hit in modern hardware. Then people are using dynamically generated access lists, and providers that know what they're doing is they're downloading the routing database and generating the packet filters periodically, like every few hours. If you have a customer, then you should know what address space that customer has. And you should filter whatever the customer is telling you to limit him to advertise only his address space. This is a bit harder. A, you have to talk with the customer. Oh, gee, what a problem. And B, you better have this automated, otherwise you will be losing too much time. And likewise toward all the peers and upstream. So you don't want to advertise everything to your competitors. Why should you give them ability to reach the customers through your infrastructure? So you should have these filters in place anyway, and the same for the upstream providers. And use RPKI, use the origin validation with certificates. And this is what Job Snyder sent in 2019, saying, well, AT&T is now using RPKI. If they can do it, there is no excuse that you wouldn't be doing it. It's like they're so big and so bad. If they manage to do it and you can't, it's a shame on you. There's no excuse anymore. Anyway, luckily, MANRS initiative has a website where they list all the participants. And you can search the list of participants, and you can see what the participants have implemented so far. And let me start with the bad news. No one from Croatia or Slovenia is on that list. So no local service provider cares enough to at least register there. Deutsche Telekom is, Hrvatski Telekom is not. Just saying. Anyway, it turns out that we can solve a lot of the problem if we solve it in the core of the internet. There are service providers called Tier 1 networks, and it's defined as a Tier 1 network should have defined connectivity toward everyone else, so they're not using anyone else for transit. So if I claim to be Tier 1 and you claim to be Tier 1 and I use you to get to him who also claims to be Tier 1, one of us is not. Okay, so no transit. I got the list off Wikipedia. There's like 15 different service providers here that are, to some definition, tier 1 providers. And 5 out of 15 implement registered for MANRS in 2022 when I was preparing the first version of this presentation that was supposed to be delivered a year ago, and then I got COVID. Anyway, which was sort of good, because today the situation is much, 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 much better. They're still missing, like AT&T doesn't care. We know they drop RPKI invalids, but they haven't registered. A lot of the tier 1 providers became participants and implemented a lot of things, and because everyone claimed they implemented everything, MANRS initiative actually started measuring those claims. And you see, for example, Comcast is really good at signing the prefixes, but doesn't document them. Whereas Deutsche Telekom documented everything they have, but didn't sign them. And so on. And the only way you can make an impact is if you vote with your wallet. And I think someone really big, like maybe the US government, did that. Because to go from almost nothing to almost everyone in a year, there must have been some carrot with the stick. So someone really big said, I will only buy from you if you meet these requirements. And you can do something similar if you're big enough the next time you are renewing the contract with your internet service providers. If you have a public tender, make some requirements in that public tender that some service providers will not meet. There was a German service provider that deployed 0 IPv6 until an analyst asked on a conference, on the earning conference call, what is your IPv6 strategy? The next morning, there was panic in the networking department. So make a security panic with your internet service providers. Because if you expect that things will get better just because we are doing the same thing all over and over again, that's called insanity. Keep that in mind. Push them hard. You know we have the tools, so there are no excuses apart from them having to get this done. And we have like 2 minutes for questions.
Well, I do work for security in an ISP operation, and I understand that there's no business incentive. It's what drives most of my security concerns insane because, from my perspective, it's a wrong approach. This would obviously make a better internet, let's face it. And the question would be, what's the best way to push from within the ISP? What's the best, what can I do to present this as, guys, we should really get this going? It's almost imperative.
You are effectively trying to generate a religious message.
Yes.
And it always works better if you have an external enemy. So it will be very hard. So you can try to educate people. Like Job Snijders has been educating people for the last decade, and he got some traction. So if you're persistent enough, maybe they will start listening. Maybe when someone will start asking nasty questions, they will remember that you know what you're talking about. It's much faster if you get an external enemy, because then there is the business pressure to deliver. Obviously, for your own good, have the answer prepared before that crisis happens. So that when the external enemy appears, you know, with a big contract, you go like, okay, I know what needs to be done. These are the things that needs to be done. This is how we can do them. I don't have a better recipe. Any more questions? We have like 5 seconds. No, I'll be around, so if there are any other questions, just ask them. Otherwise, thank you, and if you want to reach out, these are my coordinates.